And let me check to make sure we're live streaming. We should be going live here in a second. Sometimes it takes a minute. Let me just check Restream and verify that all is good on Restream. Stream has started. Stream is loading. All right, we are good. So let me get my presentation up and let me share this in a slideshow format. And let me go ahead and share my screens. How do I share my screen? All right, can everyone see my screen? Drop a 1 in the chat if you can see Foundations of REST API in my screen share. Perfect. All right. That means we are good to go. So today we're going to talk about REST APIs. REST APIs are a really important facet of how the internet works. There's a variety of different types of internet communications, but the most important one arguably is REST APIs. So we're going to do what they are, how they work, and why they matter. I will try my best to make this as easy to understand as possible for everybody. So if you have any questions, please make sure and raise your hand. And mods, if someone raises their hand, just make sure and flag me so I can take a pause and let people ask their questions. So feel free to interrupt me during the presentation. You can also ask questions in the Zoom chat. So first up is, what is an API, right? So API is application programming interface. That's the definition of an API, or the acronym's actual definition. And what an API is a way for software systems to talk to each other. And that's it. APIs are no more than a communication between two platforms that define what you can ask for and how to ask for it, creating a bridge between the two applications and services. So every communication on the internet, literally every single communication on the internet, is an API. That goes from your browser, which is an application communicating with a server communicating with a database, a server communicating with other services, authentication protocols, all these things. Think of it kind of like a restaurant menu, right? So it shows what you can order, not how the kitchen cooks it, and it provides a menu of clear options and a standard way to request them. So it's very, very simple in how APIs work. It is really defined as what you can ask for and how you ask for it. And APIs have to be documented because someone has to be able to say, you know, hey, this is what an API is. This is how it works. This is what you can ask for. This is how you ask for it. This is where you go to ask for it. So APIs in general are actually pretty simple. Drop a 2 in the chat if you've ever worked with an API before, if you've used maybe N8N or Zapier or some other platform. Okay, so we got some people that have used APIs before, which is great, but not that many. So APIs a lot of times really confuse people because they think, oh my gosh, API is so complicated. It's a different language. I have to, learn to write code. And the reality is you actually don't need to learn how to write code, and you don't need to learn anything special to use APIs because they are very simple. So an API is not a technology. It is a representational state transfer, is what REST means. An architectural style for designing networked applications. Is a very long way of saying that it's not a technology. It's a set of principles and constraints, not a specific tool or framework. And it is web native. So that means that it is designed for web applications. That's how APIs communicate. So like it's very different than how your computer communicates with an application on your computer, right? So APIs don't apply to like desktop applications necessarily. They do kind of, but they don't really apply to desktop applications that are things like maybe like Adobe Photoshop, right? So Adobe Photoshop natively edits the photos on your computer. It doesn't communicate with a web service until you go to store it in the cloud. Then it uses an API to store that photo in the cloud. So the key idea behind REST is simple. It's a predictable rules for communication. Um, Essentially, REST means that someone has defined, a global organization has defined how APIs work and what they do. So they're very clearly defined. It's a standard programming principle and constraint, but it is still not a specific tool or framework necessarily, because APIs can be very different. They can have different topologies, they can have different methods of communication, but there is one standardized language that we use when we use APIs, right? So let's talk about why REST APIs exist. So they solve a fundamental challenge existing in modern software. It's that everyone speaks different languages, right? So think of APIs like a universal USB connector that has different terms and different styles of communications because everyone speaks a different language. So for example, who here in the chat, drop what languages you're familiar in the chat. So it could be JavaScript, it could be C++, it could be Spanish, English, Czech, Russian, what Pig Latin, Spanish, French, English, and Spanish, right? So there's tons of different languages that people are familiar with. And we have to be able to communicate between those languages in a standardized format. And on the web, those languages, even the subset of those languages, Spanish, English, C++, C Sharp, JavaScript, all these different languages, even the standardization of these different languages can be challenging, right? So REST APIs came into play to make it easy for talking between different languages, predominantly using realistically an English standard format, but predominantly using a standard machine and programming language to be able to communicate. So it created this way for powering digital experiences from social media feeds to e-commerce checkouts, creating scalable and reusable connections between services, right? So think about this. Like, let's say that Francisco and I or Angel and I wanted to talk and they speak Spanish and I speak English, right? I need a way to translate between the two of them in a very standardized format. So we create this system of what is essentially like, have you ever played like a Pictionary or any of these other like graphical methods of describing things? It creates essentially a Pictionary game for the computers to talk to each other, right? So it's a known common language between a known common communication protocol between two systems. That is what a REST API is and why it exists. So you have a client server model. Now, normally during presentations, I would actually pick up the phone and call somebody, but it kind of defeats the purpose because none of you can hear what the other person would be saying. But essentially what happens is your web browser is the client, okay? And it says, can I get the user's information? So let's say that you are in high level or you're logging into any CRM or any platform and you're asking, can I get the user's information about that's using this platform? And so it requests that information from the server and the server responds, here's the user data, right? So it responds back to the client with here's the user data. And it does so in a standard format. A client, such as a browser, mobile app, or automation script, requests data or actions, and the server responds with the requested information or confirmation of the action. So it's really, really important that you understand that there's always a request and a response. And if you don't get a response, that's called a timeout. And a timeout means that you're going to the wrong address. but there is always a request made by one person and a response given by another person. So I would say, hey, Angel, and I would draw a picture of a circle and two dots and a smiley. And I'd say, and I wouldn't say anything, but I would envision, or in this case, draw a smiley face on the whiteboard. And Angel would put a check mark next to the smiley face on the whiteboard, or he'd write a frowny face on the whiteboard, right? And what that would mean is that Angel is confirming that he saw or didn't see, or he saw or didn't see, or had a response to the smiley face that I posted. So we there have two different languages, English and Spanish. One gives a smiley face, one returns a smiley face. So we have a call and response, a request and response. And you always have that during API calls. And again, if you don't get a response for an API call, that means that it's dead-ended and gone to the wrong place, or there's an error. But even in most cases, when there's an error, if you're calling the right place, there will be a response, right? So that's an API. That is all it is, a client server model of a request and response. Now, some core concepts of resources. So resources are always nouns. There is a hierarchical structure, and there are unique identifiers that are addresses. So let's say that I wanted to create an API for asking about, or let's use the smiley face example, right? So I wanted to create an API that said sentiment or feelings, right? I wouldn't say get feelings. I wouldn't say that's a programming term. I would just say feelings, because they're always a noun. And this is you'll find that some APIs don't do this properly because they're able to get away with it. But generally speaking, most programmers trained in properly creating APIs will always use standard formats when they are creating APIs. So I have things like users, not get users. I have things like users, 123 orders, users, 123 being the user ID and the order of that user. I then have unique identifiers, so each resource has a specific path that acts as its address. So think of resources as items in a filing cabinet where each resource has its own clearly labeled folder with a specific location, right? Now, inside of the resources, we have HTTP methods. These are the different types of things you can do. So different types of things you can do. You have GET requests, you have POST requests, PUT requests, PATCH requests, and DELETE requests. These different API methods are absolutely critical to what people are doing with the APIs, because they denote how you're using the API. So we've talked a little bit about in a previous slide that we're going to a specific address, right? We've talked a little bit about how it's a request and a response, but we need to tell the server what we want to do with that type of request. So the document analogy is really apropos because, or really valid, because you have get means read a document, post meaning add a new document to the filing cabinet, put or patch meaning edit an existing document, and delete meaning throw away the document. Okay, so these are different things that you have to include in your API REST requests. These API methods are very important. Without them, there is no information that will be returned because the server doesn't know what to do. So it'll give you an invalid request marker in the response saying that you haven't formatted it properly because you haven't included the appropriate information. Now, let's say that we are going to a web page. Every time we go to a web page, that is always a GET request, okay? So GET requests, we're always reading documents and asking for document information. Post requests are always where we are sending documents or sending information. And hold on one second. I'm just going to switch my audio because I'm getting a little bit of feedback. right, can you guys hear me a little bit better? Going once, going twice, perfect. All right, so what I was saying is we have get requests, post requests, put and patch requests, and delete requests. So these requests are always different types of information that we give as markers to the server about what we want to do. Now, they're kind of interchangeable in that they don't necessarily, in a poorly programmed API, mean anything. But in a properly programmed API, if you use the wrong type of request, it's not going to work. So we can have things like a request to the user's noun, right? So we go back to the resources concept and we say users, and we can have a get users request, which returns all users, or we can have a post users request, which requires a body of data that then sends the information to the system to create a user. So the same noun or endpoint is used, but what we're doing is we are either creating or getting a user. So that's the difference between the different types of HTTP methods. The next thing that we talk about is endpoints. So endpoints are addresses, right? So you have your base URL, which is things like api.example.com. You have your resource path, which is the noun, and then potentially the specific location within the request. Then we have the HTTP method, the action you want to perform, for example, the get. So this is the full example of an HTTP request going to a specific endpoint. And you'll notice that it always almost includes API or app or something like that. It's never just the raw URL. So think about it's a complete street address. So we're not just going with Main Street, 123 Main Street, apartment 4B. We're actually going down to the specific drawer in the room of the house, which is very different than just going to the raw address itself. Because the IP address or the raw address itself is just like driving to someone's house and knocking on their door. But once we knock on their door, we need to ask them for a specific location inside the house where we know that data is located. So we will actually ask them to go into their room, go to the drawer, open the drawer on the top shelf of the cabinet, and that's going to be where that address is located. Now, requests. So this is a common model of requests, right? So you have the URL, the HTTP method, the headers, and the body. The headers contain things like authentication protocols, other information. The body is what you want. So let's say that you are ordering a hamburger from a restaurant and you want to ask the kitchen to make you that hamburger. The body is going to be what you do or don't want in terms of toppings on the hamburger. The headers are going to be you handing them your credit card. The method is going to be saying, excuse me, server being the URL, I'd like to order new method with my credit card, a hamburger containing lettuce, tomato, onion, and pickles, no mayonnaise. So that is the example of what an API is. It's pretty easy to understand what APIs are. And then you get into responses, right? So response comes in, and when the response comes in, the server will process the request and provide a status code, headers, and a body. So the status code headers in a body, the status code is a 3-digit number indicating success or failure. So you have things like 200 status codes, 400 status codes, and 500 status codes. And that is what the server sends back after you make that request. So then you also have the headers that come back, and the headers can contain things like security keys, metadata about the response, caching rules. The body contains the actual data. So what was the error? What was the success? Was the status okay, right? This is all common stuff
So your meal arrives with a receipt showing what you ordered, when it was prepared, and confirmation of payment. Complete information about the transaction. That is a response from a REST API. So again, you have the client calling with what they want, how they want to order it, their credit card information, and what the order contains. And you have the server confirming, because you obviously been to a restaurant, right? And you've had a server read back the order to you, take your credit card and confirm the order. That is exactly what a REST API transaction looks like. So if you've ever been to a restaurant, if you've ever been to a bar or any other place where you've ordered something, the exact format in which you ordered something and the transaction that took place is how REST APIs work. Now you have different status codes. And again, I'm going to share this presentation with everybody. So you'll have these as uh, reference information. I recommend you take a screenshot of this page because this page contains some pretty important information. 200 codes are always a success code. 400 codes are I heard you, but there's something wrong. And 500 codes are I've got no idea what happened. There's just something wrong. And 404 is a code that says, I can't find it. Okay. So 404 is a code that comes from the browser itself, generally speaking, or a timeout from the server or something like that. A 500 code is when something went wrong on the server side. So there was an error in processing the request. 401 means that your keys didn't work. You tried to get into the house, your credit card was bad. And a 400 request means that you ordered the wrong type of toppings on your hamburger. So let's say that you tried to order and they didn't offer chili and cheese on your hamburger or an egg on your hamburger. If they didn't offer that, they'd give you a 400 bad request. The server would say, I'm sorry, but we don't offer that, or your order was formatted improperly. 401 would mean your credit card didn't work. 404 would mean they simply don't serve that type of food. And 500 would mean there was an error processing the request. The server didn't understand or was unable to complete that request. 200 success means, yes, I was able to do that. And 201 means the new resource was created. So JSON being the language of REST, JSON is kind of like a universal web language that exists inside of the API. And JSON is just nothing more than a structured language. Now, it does require very specific commas and formatting. You will notice that if you are missing a comma or a curly bracket or a square bracket in your JSON request, the request will fail because the first thing that both the sending and receiving services do, both the client and server, is check to verify that the JSON is correct. It has minimal syntax, meaning it is just a combination of curly brackets, square brackets, and comma brackets, and nothing else, and quotation marks and colons. So there's maybe 5 or 6 different types of punctuation and or formatting that go into JSON. The rest is very simple. It is a structured language for nesting objects and arrays for complex data. This is the universal language that allows for communication, or the universal formatting of that language that allows for communication of services on the internet. JSON is something that you don't necessarily need to learn. ChatGPT, Anthropic, all of the other AIs can write JSON very well. It's very easy to use. But the important piece is that you understand that it is human readable, lightweight, language agnostic, and structured language. Very, very simple JSON. It is not a complicated thing that you have to learn. Again, ChatGPT can format and write this for you if you give it the appropriate prompts. So don't be scared about using JSON. It is absolutely not as complicated as most people make it out to be. Statelessness simply means that when a request is made, it automatically is a new request. It doesn't contain historical transaction information. It doesn't remember on the server that you made a request previously. It only understands that a new request is coming in. So each request from the client to server must contain all of the information needed to understand and process that request. The server doesn't remember previous interactions or maintains session data between requests. Session data is very different. Session data is things like cookies, stuff like that, right? And when your browser that contains the cookies and session data calls the server, it actually populates the cookies and session data inside the request every single time. Why does it do that? Because it'd be really hard for the server to remember all of that information across the millions and billions of requests that most servers get every day from the internet. So it is always something that is independent and self-contained. It also means that an authentication token must be sent with every single request. This ensures that things are secure. There's effectively no conversation history that's stored on the server, and the client maintains the state and context. So this would be like the server, in the example of the food instance and ordering food. Every time the server comes back to you, you say, "Hey, server, I'd like to order another mimosa. Here is," and the server says, "Well, I didn't know you ordered a previous mimosa." And you say, "Well, I've already ordered 3 mimosas. I'd like to order another mimosa. Here is my credit card. Here is my table number, and I'd like an orange juice mimosa." So you gave the server all of the information that you needed when you were placing that order. That's what stateless means. So common use cases for REST APIs are web and mobile apps, SaaS integrations, automation platforms, data synchronization, and AI and agent workflows. So essentially everything on the internet is included in this bundle of 5 objects that I've displayed to you. So effectively everything on the internet uses REST APIs. It is a very common tool that systems are using because they have to use it to communicate. That's how browsers know how to communicate with the internet. That's how apps know how to communicate with servers, right? So everything is using a REST API. You literally cannot use the internet without using a REST API. So it's really important that you understand the concepts of REST APIs. You don't need to know necessarily how to master them or anything like that, because in the grand scheme of things, they're not actually that complicated. But at the same time, you need to know how to use them in order to be successful on the internet. So big picture summary, key takeaways: a REST API is a rulebook that keeps digital conversations organized, ensuring systems can speak the same language and understand each other properly. It is resources, HTTP methods, and predictable responses. REST resources and HTTP methods equal actions. They're predictable and web-friendly, and they're a foundation of digital ecosystems. So who here has questions about REST APIs? Does anyone have any questions before we hop off? We're about 30 minutes in. Again, while I'm traveling, these calls are a little bit shorter, but I'm just trying out some different formats. So I want to see, does anyone have questions about REST APIs? Thank you, Joyce. How would you create these for vibe coded projects? Documentation and things like that. You would simply tell the AI to document the REST APIs that you are using. That's it. You'd simply tell the AI to document the REST APIs that you are using, and it would be able to create that documentation for you. Anything you need to cover for security? Yeah, there's a whole bunch of different security things that go into REST APIs, such as headers and stuff like that. But REST APIs naturally come with security because you're always going to have some sort of authorization token or authentication token or something that gets passed. That's a bearer key that you're always passing. That's always kind of a pain in the butt to get. That's that bearer key. Dustin Trout said, is there a quick way to understand what endpoints to use based on the documentation? Use AI? Yes, I would use AI. Um, to build or read JSON, you always want to use AI to do that, and you want to pass it the API documentation. Is this API different from an API key, or is that the key portion of the API overall? So the key portion is in the header of the API communication. So remember, APIs are like a menu of services and a type and how to communicate, like what you want to communicate and how you want to communicate it. The API communication itself, the transaction, right? The transaction is the API call. That's where you're ordering the burger from the server, providing your credit card, what you want on the hamburger, and saying that it's a new order. Okay, so there are different tools, and I'm going to publish a little Loom in the community of the practical application component of this presentation that I did at AI Unleashed. And the practical application component contains how to use Postman to test your APIs and a bunch of other information. Yeah, so Angel, you can do a lot more if you learn to use API calls. They're really not that hard, buddy. I mean, ask ChatGPT to simulate some API calls for you. Give it high levels documentation, and then using that, you'll be able to understand better what you're doing. Do I have any other questions before I let everyone get out of here about 15 minutes early? I am having a Diet Coke. I've been walking all day and enjoying the St. Louis Arch. I'm actually in St. Louis right now. So I just got in from Las Vegas last night, and I'm in St. Louis, and went and visited the Arch, went to an AI little summit. The walking is coming great. I actually walked a lot today in person, not on a treadmill. So I did a lot of walking in Las Vegas. It's been great. I haven't been home for a couple weeks, so I haven't had a chance to walk on my treadmill. But definitely the walking on the treadmill is pretty awesome. So yeah, Vegas was a lot of walking, lots and lots of walking. Even walking around the casino was a lot because the casino was huge. I don't gamble though, so I was just walking past all the tables, making fun of people. But all right, everyone. I hope you have a good rest of your day, and I will talk to you all shortly. And thank you so much for attending today. I will see you all on.